Hello and welcome to my video, lesson 1.2 on number sets. So we're just talking about different types of numbers, and to start with, we really have to talk about the two overarching number sets, which are real numbers and what's the opposite of real? Unreal or imaginary. So there are real numbers and there are imaginary numbers, and every number fits under one of those two categories. Okay? Actually, this is scrolled down just slightly too far. There you go. Much better. Real numbers and imaginary numbers. So let's talk about some examples of each of these. So real numbers are basically every type of number that you've ever looked at so far in math. Imaginary numbers are basically university math. And not just any university, but very, very hard university math. And it's, like for example, I took a Bachelor of Science, and only one course in my mathematical sciences minor, so my math minor, only one course was about imaginary numbers. It's very complex, it's very difficult, and that's a funny joke because it's complex numbers. Another word for this is complex numbers. So anyways, they're very complex, they're very difficult to do, and this is what imaginary numbers are. Any sort of square root, or more specifically, or more generically I should say, any even numbered root of a negative value. So in this case, this is like the most basic imaginary number. Okay, it's I, this is the imaginary number. And then any version of I, so if we said like 3i, that would still be imaginary. Or another way to say 3i would be like 3 times negative 1. Or if we said negative 9 inside, well, we know how to get the answer for 9. The answer for square root of 9 is 3, and then there's the negative, so we'd say this is 3i. So anyways, any sort of negative square root, or fourth root, or sixth root, or any even numbered root. Okay? An odd numbered root, negative root, would be fine. That would be a real number, but all of these will give you calculator errors. Calculator will be quite upset if you do this. So it'll say non-real answers. Okay, depending on your calculator. Okay, let's take a look at what type of real numbers there are. Well, underneath real numbers, there are two different types of real numbers. There are rational numbers, which are the majority of numbers that you think about, and there are irrational numbers. Irrational numbers. Okay? And all real numbers fit under those two categories. Okay? So real numbers have rational and irrational. Imaginary is completely separate. And actually, I'm going to give myself a little bit more room to work with here. So, irrational numbers include numbers that have non-repeating decimals, or another way of saying that is anything that does not equal a fraction. So, for example, 3.1415 ... for pi, that is irrational. Okay? Or square root 2. Because the square root of 2 does not give an exact number. Let me show you what I mean by that. Square root of 2 does not give an exact number. So 1.41 blah, 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 blah. It doesn't repeat. It doesn't give an exact number. It cannot be expressed as a fraction. So 1.41 ... Another special irrational number is the letter E. So this is can be shown right there. So that is Euler's constant, and it's 2.718 dot 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 dot. So E is 2.7, and I'm just going to say 2 dot 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 dot. Okay, so those are all irrational numbers. Is square root of 4 an irrational number? Think about it. No. Square root of 4 actually just equals 2. So it is not irrational. Okay? So now let's hop inside of rational numbers and look at what makes a rational number. A rational number is any number that has that can be expressed as a fraction. Okay? So there are plenty of numbers that can do that, but basically, let's just talk about fractions for now. So 1/2 counts. So does 5/7. So does, let's say, 4/3. Okay, so if it's bigger than 1, that's allowed. If it's less than 1, that's allowed. If it has a repeating decimal, like 4/3, that's allowed. So you can see this here is repeating, that's okay. Or 5/7, it does repeat, it just takes a long time for it to repeat. So it's 7, 1, 4, 2, 8, 5, and then it repeats 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5. So it does repeat, it just takes a while. And it's hard to tell if something's going to repeat just by looking at the numbers. But basically, the rule is, if it's a fraction, it's rational. Okay, so those are rational numbers. Let's go down the row. Actually, even let's start at the basic numbers, because it's easier to start down here and talk about natural numbers. Natural numbers start at 1, and they're just counting, dot, dot, dot. So 1, 2, 3, 4, all the way to infinity. Those are natural numbers. So natural numbers include all counting numbers that you would have learned when you were pre-kindergarten, okay? Or perhaps in kindergarten. Okay, next, after natural numbers, we have whole numbers. Okay? Whole numbers are the same as natural numbers, except that it includes the 0. So 1, 2, 0, 1, 2, 3, dot, 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 all the way to infinity. Okay, and then our last number is going to be, or number set is going to be the integer, which is starting in the negative. So all the numbers, and then I'm going to write -2, -1, 0, 1, 2, 3, dot, 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 and it keeps going to infinity in the negatives and in the positive direction. Okay, so if it's a natural number, it's automatically a whole number and automatically an integer. If it's a whole number, it's automatically an integer. If it's an integer, it's automatically also rational and real. So if you pick any one of these, it's also everything above it. Okay, and notice that a rational number could also be like a fraction, could also just be like a straight up number. So it could be like 2/1, and that counts as well. Whoops. 2/1, which is just 2, right? So that certainly counts as well. Okay, so let's go down here and you're going to try this out. Pause the video, try these questions, and then press play and see if you get it right. Which number sets do the following numbers belong to? So I'm just going to go ahead and quickly check off which ones they do belong to. Since the first number is square root of 9, which is 3, 3 is a natural number. I'm going to actually start on the right and move left, because if it's a natural number, it's also a whole, it's also an integer, it's also rational, and also real. Okay, cube root of 4 is going to be a decimal, so it's actually going to be irrational and real. Negative 12 is going to be an integer, rational, and real. 789 is going to be natural, whole, integer, rational, and real. 4 over 3 is going to be rational and real. 1.75 is going to be rational and real. The decimal has stopped, therefore it is rational. And this one, in 4 over 3, the decimal repeated, so therefore it was rational. So both can be expressed as a fraction. Let me just show this one to you. So this would be 7 over 4. Okay, I just quickly did that in my head. Okay, pi is irrational and real. Okay, and the next one, because it's a negative inside a radical and it's a even number root, this is imaginary. 0 is a whole number, integer, rational, and real. Okay, yeah, so hopefully this little check was helpful, and hopefully it explained number sets a little bit more clearly for you. Hope this video helped, and good luck.